All right, we are gonna whoops, let me get rid of this. Let's draw a line right here. In fact, it's not just a line, but I'm gonna put a little endpoint here and endpoint here. So what is it? It's a line what? It's a line segment. It's never ending when it has dots on the end. If it's never ending, it would have arrows on the end, okay? And we would just call it a line. Okay, try it again. This is a line segment because it's got endpoints on the end. Okay, it's not a line because it keeps on going. What I'm going to do here is, let's find where that would be. Okay, that point right there, I'll call M. I'll call this A, call this B. We'll call this M right here because where does it look like it is? Right, it's the midpoint. Right, it's the midpoint. It's in the middle, I guess you could say that, but we say this point is the midpoint. So what does the midpoint do? It divides the whole entire segment into what? Yeah, but remember, we don't like to say into half. I mean, technically that's true, right? I like to say it divides it into two equal parts. Okay, so it divides it into two equal line segments. Yeah, technically it divides it in half. Okay, but we don't have theorems. We don't refer to it as dividing it in half. We say that it divides it into two equal parts. The reason we don't say it divides it in half, we say it divides it into two equal parts because if this is the midpoint, then what? AM MB, right? And see, that's our definition. If we have a midpoint right here, excuse me, it divides that whole segment into two equal parts. That way I can put a little tick mark here, a little tick mark here, means those two parts are equal to each other. Make sense? We also say, what if I had a line and it actually went through the midpoint? What could I say about that line? And we've used this word before. It bisects. Very good. Okay, so this line right here, it bisects the line segment. Everybody with me? So I could call this line, I don't know, we'll call it line L. Line L bisects line segment AB at point M. That means point M must be the midpoint. That must mean that AM and MB are equal to each other. Everybody see that? Okay, so the line hits right here at the midpoint. It divides that whole segment into two equal segments. So we have the word bisector, don't we? So we say line L is a bisector. It bisects this segment, the line segment. I'm going to get a little bit more specific. What am I doing? There we go. Let's get rid of this. What if I had a line that goes right through, but it doesn't just go through. Now it is a bisector, isn't it? This line right here, just like that other one that I drew was a bisector. But I drew this so that I've got a right angle right here. So what's true about this line, we'll call it L again. What's true about line L and line segment AB? They're what to each other? Give me the word. They're not congruent. A line and a line segment cannot be congruent to each other. They're perpendicular. That right angle right there means they're perpendicular. So if two lines form a right angle, the lines are perpendicular. Everybody got that? So this is two things now, isn't it? This line L. What's it doing? It's hitting the midpoint, so it's a what? It's a bisector. And it also hits it at a right angle, so it's a what? It's perpendicular. So we call this a perpendicular bisector. Very good. All right, so it does two things, doesn't it? It's perpendicular, and it bisects that line segment. That's what we're going to work with today, okay? A perpendicular bisector. Does it make sense? That's not too hard, is it? All right, so two words, perpendicular bisector. We've already talked about those two words previous. We just haven't put them together when we've talked about this thing right here. So line L is a perpendicular bisector. Now, let's go a little bit further with this. What if I had a point on the perpendicular bisector? Remember, line L is the perpendicular bisector. AB is not the perpendicular bisector, okay? Because I'm not bisecting line L. I'm bisecting line segment AB. Everybody see that? So line L is the perpendicular bisector. If I put a point on the perpendicular bisector, and if I happen to start at that point, and if I wanted to connect to the endpoints, so that means connect to A and connect to what? To B. What do you think, just guessing, what do you think might be true about, excuse me, about these two lines right here? Well, let's call this C. So what do you think is true about AC and BC? They're congruent to each other. They're equal to each other. Exactly right. Now, you probably say, well, how do you know they're congruent to each other? I'm not going to measure them. Let's look at this. Do you see how I have a side? See this triangle right here and this triangle right here? Look, do you see how I have a side equal to this side? If this is a right angle, guess what this is? That's a right angle. So I've got a side that's equal to this side. I got an angle that's equal. And what else do I have? Another side. What's the other side? CM. CM is the other side, right? So look, I've got a side, I've got an angle, and I've got a side. Same thing on the other triangle. A side, an angle, side. What's true about these two triangles? What's true about the two triangles? They're congruent to each other, okay? The two triangles are congruent to each other. Now watch. Now I can't do this, but what if I was able to take those two triangles and fold it so they lie right on top of each other? Well, no, they wouldn't make a square. All right. What do you think would happen to AC and BC? Watch. I take it, I fold it. Everybody looking up here? I fold it, and it comes together. They're sitting right on top of each other. AC and BC would be exactly the same, wouldn't they? Do you see that? So that means that AC equals what? BC. All right. Everybody with me on that? Actually, I put 3. I know. Yeah. Okay. All right. We with me? So watch. What if I did this? What if I picked another point on line L? I don't know, let's say right here. And let's get rid of some things. Well, let's just get rid of this and this, just to get it out of the way. All right. So watch this. If I, oops, sorry. Go back to blue again. If I did this, if I took a point right on this perpendicular bisector, and I connected from that point on the perpendicular bisector to A. Now this is a different line segment, isn't it? It's not the same as AC. Tell you what, let me try that again. Get it to hit right on there. That's a little bit better. Okay, and now I take this and I take it to what? The other endpoint, to B. What must be true about those two blue lines? They're equal to each other. Okay, they're congruent to each other as well. All right, you see that? I could do it again. Let's go with a different color. Let's go, I don't know, let's go purple. Well, that purple might look a little bit like the red. Let's go green. Let's go green. Okay. So watch. What if I had another point? Let's put it down below this, just to make it look a little bit different. So what if I had a point? It still lies on the perpendicular bisector, doesn't it? So if I connected from that point to the endpoints again, just like it did up there, what do you think's true about those two things? They're congruent to each other as well. All right, do you see it? So what we have is this. If we have a perpendicular bisector, then what's true about these two lines from a point on the perpendicular bisector to the endpoints? What's true about the lines? Then we'll call it the sides. Then the sides are what? Are congruent. They're equal, aren't they? So if the point, now watch, I didn't just put a point anywhere. Watch, if I just put a point way out here, and I connected to B and I connected to A, are they going to be equal to each other? No. Absolutely not. Where does that point have to be? On the perpendicular bisector, okay? So it's got to be on the perpendicular bisector. Anywhere on this line, no matter how high up, no matter how far down below, as long as it's on that perpendicular bisector, if I connect it to the two endpoints, those two segments are going to be equal to each other. You with me? Watch this. What if I said this blue, let's go to the green one. What if I said the green one was 5? This is the information I gave you. All right? And I tell you what, just to make it a little easier, just let's get rid of all that. Let's get rid of all that. Okay. What if I gave you this thing right here? This is a perpendicular bisector, isn't it? How do you know? Because that's the midpoint. This segment is equal to this segment, and it's perpendicular. It's got a right angle. I took a point on the perpendicular bisector, I connected it to this endpoint, I connected it to this endpoint. If I told you this line segment was 5, just by looking at it without doing any math, what is this line segment right here going to be? It's going to be 5 as well, isn't it? Does it make sense? Okay, so you could kind of see what they're going to do on the problems they're going to give you. We'll do an example in a little bit of something that you're going to see on the homework. All right? We're almost finished. Watch. If we have a perpendicular bisector, then those two sides, we'll just call it these sides right here. These two sides would be equal to each other. What if I flip that around? What if I flip the if and the then around? Instead of saying if we have a perpendicular bisector, what? If the sides are what? Equal to each other, then guess where it lies? Where does that point lie then? It lies on the perpendicular bisector. Now, I really shortened that up. Okay, I was really I left out a lot of details here, but you get the idea. If these two segments, watch, if I told you, let's do this. Let's please do. Watch, if these things right here, let's get rid of all this mess. Okay, here's what I told you. I said that, yeah, we'll just leave it like this. What if I said that this right here, we'll call it D. What if I said AD and BD were both equal to 5? What must be true about line L then? It must be a what? If the sides are equal, then what's line L? It's a what? It's a perpendicular bisector, which means what kind of an angle must be here then? That must be a right angle. And what must be true about AM and MB? They must be equal to each other, right? Do you see the difference? One time I said, okay, we're starting off with perpendicular bisector. Then these two sides must be equal. But what if I didn't tell you it was a perpendicular bisector? What if I told you just those two sides were equal to each other? And what would be true about this line right here? It must be perpendicular, right? And this must be the midpoint, which means AM and MB are equal to each other. All right, does that make sense? That's the converse. That's the statement itself. And guess what they call this? Okay, it's not that, you don't have to be that creative. Since this is a perpendicular bisector, they call this the perpendicular bisector theorem. That's right, okay? So not much of a stretch, is it? Okay, that's the perpendicular bisector theorem. This is called the converse. Converse is when we take the if and the then and we do what? Switch places, okay? So this says, if it's a perpendicular bisector, then these two sides are equal. This one says, okay, what if the only thing you knew is what those two sides were equal to each other? What could you tell about this angle? You could tell that it's a right angle. What could you tell about these two sides? Those two things are equal to each other. Does it make any sense at all? Yes. All right, that's the kind of stuff that you're going to be doing. Let's do an example real quick before our time runs out, and then I'll give you a worksheet and you can work on that.